All right, so first thing I want to do is discuss measuring tonight. Now, so far we've been pretty much going with just kind of free flow, making things that are relatively the size you need and such. Now, the project we're working on, make the snap fit joint tool is not needing to be exactly photorealistic, but you do need to accurately measure parts so that things like your tolerances and clearances are within spec. What that means is your objects need to have the right dimensions so that they actually move past one another and work properly. And we're going to be using tonight, first, just a couple of simple tools. Basic ruler. Now, as I said before, a lot of stuff we're working with, specifically 3D printers and such, usually default as millimeter measurements. So I recommend using the metric side of these. We also have a simple pair of digital calipers. Now, there's a bunch of different types of these that are much more complex, much more well-made. These are just cheap plastic ones. They come in metal usually, and often they have different settings. This one has simple off and on, 0, and millimeters to inch toggle. What that means is, obviously off and on is off and on. Your 0 fitting, your 0 button is, say you bring it back to closed and it's not quite reading 0. What that means is there might be something between the jaws. So make sure to give a little sweep there, close them up, and if it's still not reading 0, press 0. All that means is it just needs to be recalibrated. And since these are digital, you don't have to worry about resetting any knobs or anything like that. There are other calipers that have a dial or vernier calipers, which are like the older slide rule calculators. That's not these. So we're just going with this. The other thing, of course, is inch to millimeter. Now, these do not have the fractional settings. Some also have fractional. This is just decimals. So it's either millimeters or inches, and that's just decimal points. So you're working with that. But I recommend leaving it in millimeters. It's going to be the best option and such, just because it directly translates to things. So how you use these, there's two different parts. As you open it, there's the jaws between these 2 points. That's for measuring outside dimensions, meaning like you can grab the outside of something and get, okay, this pair of pliers is 7.8 millimeters wide. The other ones on the back end, they start full and then they go inside and kind of cross over one another. That is for measuring the inside of things. So in between, you can stretch the backside and decide, okay, so between the two ends of this pair of pliers, it is 25.2 millimeters. So these only go down to just 1 decimal point on metric. And for what we're doing, that's plenty fine. So that's how those work. It's pretty straightforward. And we're going to experiment with them more as we work. But I just wanted to briefly go over how calipers work. So it's either you have 2 sets of tools. It's the inside and for outside measurement. Or sorry, the teeth are on the outside to measure the distance between something. And these teeth are on the inside to measure internal diameters. Or spaces, rather. Usually meant for measuring circular things, but you got a variety of tools, or you've got a variety of things to measure, and that's all it takes. All right. So let me switch over, and we're going to discuss what we're working with tonight. So the aim of the project is, and this is an imported model, the aim of the project is we are making a pair of pliers. Now, I'm going to be modeling a pair of needle nose pliers as the example. You pick something that you can find because you need to be modeling from something. These are much more of like simple toy models. But one thing I do want to quickly go over, the reason these have all of these different lines and facets on them, this is imported as a mesh. We have not discussed this yet, but the way that Fusion imports models that you can download from the internet and such, it imports them usually as meshes into this project. Now you can upload them directly as the normal project and it'll operate differently, but I have found that it throws off the scale really badly. And there doesn't really seem to be a standard for why it scales things the way it does, meaning that it could come in, say as like, maybe the whole thing was like, I don't know, 60 millimeters long, and it'll import it as like, I don't know, I've had it import as like 200 millimeters long. It's very strange sometimes. So when you go to upload a project, if it is already an STL, or rather not as a pre-formatted Autodesk, it does weird things. So how you have to do that is go to insert, just like we did for the canvas, but instead insert and insert as mesh. And then for here, you can see I selected one of the pliers and such. But it'll import them as any of these things. So 3MF, OBJ, or STL files. It's fine. Anyway, that's a discussion for another time. For now, what we're talking about is this needs to be a mirrored set of pliers, or two-sided tool. But the other thing we're working with is, let me hide one of them, is we are modeling these with the joint already built in. And what I mean by that is, look at how this is created from profile. This center pin here, and it is molded directly into the object. It has these, in this case, 4 tines that have a flared top to them, just this little top. And the idea is those 2 halves, once they are 3D printed, squish them together, and they will rotate along that pin. Now, a couple of issues with this I can already tell you is, looking at this model, this angle is much too sharp, and this point is much too thin. This will break if you 3D print this, or rather, this will break if you push them together. The other thing is, as we just briefly discussed when it comes to creating snap fit forms, if you were to print this on its side, so if you were to orient this in a printing slicer like so, these would become very weak points. We're going to discuss ways to strengthen that, namely with fillets down in the bottom here, and then shrinking this upper lip and such. And ideally, it's these tabs that are going to flex just enough to allow it to pass through there, through the eye of the other half, and snap in place. Now, looking at this, the idea there being that that overhang would fit on this chamfer, or this chamfered edge on the other half of this piece. And you can see there's a chamfered edge on the inside as well. That should allow those tines to squish in just enough to snap back out and snap into place. So we're going to talk a little bit about that. One of the things that we discussed in this assignment is, keep in mind that when it comes to 3D printed parts, you want to leave a gap between things. Do not expect to print this or model this to where it's an exact fit. Say this whole circle is 10 millimeters, and I make the inside 10 millimeters, and I make this other side 10 millimeters. There's not going to be enough space. So what that means is, model this, design this to be a 10 millimeter circle. This side, and I'm sorry, I'm having difficulty selecting because of the way this is faceted. One side would be, maybe that side of the circle is 10.1 millimeters. And then the other side, the outside of that circle would be like 9.9 millimeters. So that would leave a 2 millimeter gap, which might be too much, but we'll find that out when we go to print these, or if we print these, because you're going to get some plastic squish between the layers and such, which will then actually take up some space. So there's a lot to go into this, and I'm not expecting everybody to immediately knock this out of the park right out of the way, because that's not how this works. But with these things considered, you'll have a much higher chance of success. All right. So with that, what you want to do is get your measuring tools together and your object together. So if you're following along in class, great. If you just want to follow along with the actual project in your own time, that's also good too. So let me get my stuff together and we will get underway. So for a moment, I'm just going to pause the video. Oops, I meant to pause the video. Resume recording. Okay. All right, so we've got the basics there. And like I was just saying, that this simple pair of pliers would very much allow for this sort of design. A minor drawback to this project is, if you were, or we were be modeling, like for myself, this pair of pliers, if you were to design this with or print this with a snap fit joint in place, it might be too small to actually print, and it might be more delicate than you would like it to be. But we're going to practice. It's more practicing with taking measurements and considering this sort of design feature, because when you actually goes to printing, it can totally depend on the capabilities of the printer you're using, how not so much how strong it is, but more of the tolerances that it can maintain. So we're going to practice with taking accurate measurements, and then we can always expand on this idea later for actual direct printing. So with that in mind, let's start a thing. All right. So we're going to start fresh. And what's the best thing to do when you start a new model? Save it. Because we're going to see if I can manage to not crash this tonight. Sample 2. Snap. Bit. Needle nose pliers. Super long title for super long project. Not at all. All right. So first thing you want to do is, now what we said before is, yeah, obviously save your project. If you crash your program or whatever, at least it should be saving. If you don't already start with a saved file, it has nowhere to save it other than just the standard crash file folder. So save your project. It actually has a chance of saving. What you want to do first is really establish what you're going to be modeling. In this case, this pair of needle nose pliers. It's a little small. Like I said, it could be problematic for actual printing, but we're going to go from there. Next thing is, I highly recommend starting with basically just building a bounding box. What that means is I'm just going to start with a sketch that just has my general dimensions for this thing. How big is this actual project? That way I know at least what I'm working with. Now, in the past, we've worked with starting with a dimension and building inside of that. This, we're going to build just a rectangle sketch, taking into account how large this actually is. Now, this pair of pliers is missing one of the handles, so we're going to kind of work around that, but that's okay. So essentially all I'm doing is I'm just measuring how wide is it. So from side to side, it is about 50 millimeters. All right. Then from end to end, that is just a little bit longer. So we're going to say 160 millimeters. So what I want to do then, I'm going to start a sketch looking straight down, and I'm going to create a center point rectangle. But what I want to do is start there, but I'm going to immediately switch to a construction plane, or a construction line, sorry. So you can either select it on the toolbox or press X. I'm starting right in the center. That's all right. Doesn't necessarily have to be at the center point, so whatever. But what that means is it is 50 millimeters wide and 160 millimeters long. Okay. That just gives me a frame of reference, somewhere to start. You don't have to start this way. I like starting this way. It just helps me visualize my object. Also, what it does is I can start with another line, like say straight through, doesn't matter where, outside, inside, just so it goes straight across. But I want to make sure, yeah, sure, 200 doesn't matter. At 0 degrees, good. I have now another construction line. This shows me I have a place to bisect my object, because any of these, like pliers, tweezers, tongs, scissors, they're all essentially, they're not exactly, especially depending on your scissors, but with the other stuff, it's bisected right down the middle. So that gives me a good reference guide of where I'm going to go from there. All right, so I'm going to finish this sketch. Since we're going to be making a few sketches here, I'm just going to go ahead and label this immediately as reference box. That's all. Helps me out. I like to label things. I get confused, and so if I label stuff, it helps me a lot more. So to start with actually modeling, remember these need to be in separate components. Doesn't hurt to start with a new component. Now, I can start with a new component. Yes, you should. But I'm not going to work on that just yet. So this will just be side 1. Now, the reason for this is normally you would start by starting on working with that side. All right, yeah, I'm gonna model that side. However, I'm going to be modeling half of this pair of pliers, and then I'm going to be mirroring it to create the other half. Actually, in this case, I think it actually works better by rotating. Either way, what that means, though, is that it's easier and more effective for this project if you instead keep your sketch on the full project activation. so that you can more easily access that single sketch from either or other components. What I mean by that is if I create my sketch for one side of the pliers within one component, sometimes it's more awkward. It's not more difficult. It's just it might take additional steps to pull that second side as a second component. But if I keep the sketch in the main piece here, or in the main area, and then pull the extruded bodies into the component, sometimes it's a little bit easier. But if you prefer, there's no harm in also starting your sketch within that second side, or within one side, and then creating another side. Doesn't really matter. I'm telling you that it can cause issues down the way for a project like this. But let's start here. I'm working with it. I started my second component, but I'm going to stay right here for now, because now I'm going to create another sketch. Same plane, same place, same time, all that. And I'm going to just start modeling one half of the pliers. Now, don't forget, pliers, scissors, all of that, they crisscross. You're not making one complete half. You're making half of the jaw, then the other half of the handle, because that's the actual side. So let's get started there. Me, I prefer to figure out where my center of movement is. And the easiest way to do that is I'm going to use my calipers. Again, I'm working in metric, and I'm going to measure what is the diameter of the little circle for the pliers there, of that cylindrical part. It is, says 15.8, 15.9, 16. Looks like it's about 16. These aren't exactly the most absolute exact measurements or calipers, so we're going to go 16 millimeters. So I'm going to start with a center circle somewhere on this line, and I say somewhere because we're going to move that in a minute. Right there, and 16 millimeters. Okay, there's my starting point. Great. Next thing is, what I need to do is measure from the tip of my pliers, because I don't have a hole to work from in the center of these pliers. I'm going to measure either from the start or from either end, either the closest or furthest of that circle. How long is that? So we'll go with, you can use the calipers, you can use a ruler, doesn't matter. I'm going to start at the closest edge of the pliers there, and then to the very end, looks to be about 51 millimeters. So what that means is, from this circle here to the end is 51 millimeters. So what I can do is either I can draw a line here, make that 51 millimeters. Then I can move my circle over, or I can use the sketch dimension tool to select there and to this circle. It's not going to let me do it. I've already drawn that line through there. You can create dimensions through here using the sketch dimension tool, but that only works if you're working in the center point. So sometimes it causes issues. All right, that's okay. So let's just select the whole thing, as in the circle I'm trying to work with from here. Let's move. Now, I can move from the center to the center, great, but I need that edge to snap there. Now, because I'm working with whole numbers, I should be able to snap to that edge. But if I can't, I can either deactivate the snap, meaning that it's not going to snap to whole numbers. If you need to do that, you go down to grid settings or grid and snaps, and then deselect incremental move. Now it'll move much more at a much finer degree, but it sometimes can create awkward things. So let's Control Z that, reactivate incremental move. So instead, what I want, double click or use the selection circle there, or selection box, hit move. I can use a point to point. So what I mean by that is, let me select the point to point tool. See if it'll let me create a point on this circle, selecting there, and then the end of, where's my dimension? Right there. Nope, no point on the circle. Crud. Okay, well, let me do it. That's fine. Let me try the other one. ultimately, I just want to go through some options here that should allow you to work this way. We got a circle. Let's see if it'll let us work with the tangent. I don't think tangent's the way to go with this. Come on. Nope, not gonna let me. Okay, so with that, that means you're just gonna have to snap it in place or move it in place manually. That's okay. So reselect everything, use the move tool. Gonna drag over, and essentially what I want is I just want that edge to line up right there. Now there wasn't a point for me to work from, so that's okay. Right there. Ultimately, the other thing would have been is I could have taken that measurement first. Select okay, that's fine. Ultimately, I could have taken this length measurement here from the point of the pliers to the side of the circle first. And then instead of creating a center point circle here, I could have then gone to create circle, 2-point circle, ended it on that point, and then created my 16 millimeter circle that way. So 2 different ways of achieving the same thing. If your constraint tools aren't responding how you want them, that sort. Now the difference there is either way, if I used a 2-point circle or a center point, that is now synced to the edge there. So what that means is I should be able to, if I decide, if I'm measuring things and realize, oh no, that wasn't 51 millimeters, that was actually 50. It's not synced. I would have to manually move the circle there. So let's go ahead and nip that in the bud. Easiest way to work then. I want things to work better for me. Start a 2-point circle right there. It needs to be 16 millimeters. Snaps on the edge there. There we are. Okay. All that does is I'm going to just turn that original circle into a construction line. There we are. All that does is now that this new circle, it's the exact same circle, I just made it a 2-point circle instead of a center point. What that means is now it's linked to the length of this center line here of the pliers. So I can change that center line length, and that circle will move in line with that. So it's just an easy way of linking things. And then if you have to make moves and such, the whole drawing will move around with it. Sometimes that gets really problematic, but in this case, it should be okay. All right. Blah, 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 blah. Main things are important that now I have. That's right where the center point of my center of movement will be for my pliers. And it's also the starting point from where those pliers are from the edge of the circle to the tip. Okay, the rest is pretty easy. All right, how tall is this pair of pliers? All right, 18.4, great. So let's create a line up there. Let's just create a reference line somewhere along here, going up. And I need half of that, so that's 9.2. There we are. And now I can just draw a line straight out. It didn't continue the line, straight out. And make sure that is 90 degrees. There we are. And tab, I'm just going to draw it out here. Doesn't matter yet, just yet. I'm going to draw it somewhere out to there. All right. That's now telling me how tall this section is. All right. How tall is each one of these flat end teeth? Oh, that looks to be about 3 millimeters. Cool. So now down here, another line. Let's draw that at 3 millimeters. All right, right there. Let's hide that, or not hide, but let's make that a construction line also. Make some stuff easier on myself. And then let's see here. Somewhere out about there. We can try to estimate how long essentially that hypotenuse is. Or you can also decide how far back does that line start. And it's a lot easier with a pair of calipers. What I'm doing is I'm measuring to the heel of the top here and to the point of the needle nose. And that is 56.7. All right. That means this line should have been 56.7. Easy way to fix that, not double click on it, is it's trying to select extra things. Bring up your dimension tool, select that line, bring it up, That's 59.8 repeating and such. I instead want that to be 56.7. Shrinks back down. Cool. What that does now is that now tells me exactly where that is. Great. Now how far of that flat spot, instead of trying to measure the hypotenuse of that the angle of that pair of pliers there, let's just measure the flat spot, and that's more of about 14 millimeters. Cool. So from that little heel here, oh no, right there, 14 millimeters out is to there. Great. Now I can draw a line between that point and that point. Great. And then I just need to drop a line from here straight down to where it intersects with the circle. Great. So what I was just creating is that side of the pliers. Let's change some of these lines to construction lines just so I don't get too confused. What'll happen? There we are. All right. The other side is now I need to create the handle out here. Now this gets a little bit more freeform because I'm not expecting you to exactly duplicate this arch, but we're going to try and get close to it. So first thing is, how far apart is this? So from the inside to inside is 25.5. Outside to outside is 39.3. We'll probably just estimate those. So let's cut those in half. Oh, you know what? We're going to round out. It says 25.8, 25.9, depends. We'll just call it 30. So I just need half construction line for this. We'll call that 15. Wait, what did I say? I keep getting different measurements for stuff, so that gets problematic. Yeah, 20. All right, now it's saying 25.5. Again, one of these has a handle, the other one doesn't. I would select something that actually is mirrored. All right, well then fine. We'll call it 26. That way, again, I can just say 13. Makes stuff easier. Good. All right. And then ultimately, how wide is it on the outside? We'll say it's 40. So that means another line at 20. I'm just making halves. Great. So what that means is now I'm going to make one more line right there. Let the tool do the work. I've got a center point somewhere in there I can work with. Cool. Okay. Next part. I got this little set of jaws in the back here. How far back does that go? That's about 10 millimeters. Okay. Center out. Let's say about 10 millimeters. I don't want that to be a construction line, but I'll change that in a minute. There we are. Okay. Now, one thing, just remind everybody, if you are having difficulty selecting a line with you have overlapping lines, press and hold the left click. It'll bring up a little drop down, and now you can cycle through which one you're trying to get at, and it'll highlight which one it is. I'm trying to get just that short little 10 millimeter one. There we go. Press X. I wanted that to be a solid line. All right, great. Okay, so from there, now I can say how thick was that handle. It looks like it's about the same that the first side was, so 18.2. So we'll say 9.1 or 9.1. That's fine. All right. Oh, let's go straight out. 9.1. Great. Now it's creating everything. That's all right. A construction line is what I want. All right, that's okay. All right. One other thing, good gravy, is I want to make sure that my spacing between the two halves there is correct. So I want that little heel there. That is 7.1. I'm using the inside calipers. What I'm measuring is from this point to what would be the other side handle. So what I can do, start a line here and go 7.1. Make sure that's 0 degrees out. Great. Oops, I didn't want the tiny line there. What's going on here? Didn't mean to create that little tiny bit there. All right. But what makes that easier there, now I can just take a line, go straight down. I forgot to measure how wide that was. That is, oh, right, 18.2. 18.2. Great. Now I can just go straight out, switch back to regular line, there to about there. Should have measured the heel there. Yeah, the edge of that line. That works. Great. Okay. There. And I'm just completing that little chunk. Okay, so now I have the, that, look carefully. I just realized what happened there. That was not 0 degrees. That's a problem. So let me delete those lines and just recreate that. I accidentally, when I measured outward, somehow it did not stay at 0 degrees, or 180 for that matter. There we are. All right. Looks like I just accidentally didn't go all the way with that line. That's all right. Close enough. Close enough. I just want to make sure that is straight down. And again, to the edge of the circle. There we go. Goody gumdrops. Okay. So that's just creating that heel part. The rest is, yeah, kind of free form. So I'm just creating the handle. We use a fit point spline for this. Go outward, something, something, right about there. Okay. Same deal. I could create a new line or use the offset tool. Just go outward till it matches up. And how thick is that? Or rather, how far off did that need to be? 9.1 should be about there. Doesn't exactly match, but we're going to move that around until it do. Let's try to bring that more so it actually lines up. Not sure why it didn't match up to that. That's all right. That works. Thinkify. Great. So I just use the offset tool to just create that edge. Excellent. We'll trim those parts off that I don't need. All right. And then the last part is just close up this line. Now, realistically, what should have happened is I should have double checked the measurement here. So let's do that. Use the inspect tool, measure from that point to that point. 7 millimeters. Okay. So yeah, that's going to bother me. So I'm going to delete that first offset, go back and reuse it again. Should have been 7 millimeters. There we are. Not sure why there's a notch down there, but I will fix that in a minute because now at least it matches to there. Good. Last bit. Point to point line. Close that up. And the same thing goes for over here. I just need to clean that up. Easy way to finish up this line. I'm going to go to modify, extend this line here, and it just extends that line out to those two intersecting. Excellent. And just trim up the excess mess. Now, something's going on here. You see that this section, these two sections over here are highlighted blue, so they're closed sketches. Over here, it's not. Now we get to figure out what is missing. Nope, nope, nope. Let's go check the other end. Make sure this line is connected. It should be because I use the extend tool. Let's go to the other ends here. Let's see. Something might not have gotten connected back here. Don't know why. Tell you what, let's close. Let's hide the original reference box. Not sure what's going on there. Aha. All the way down there. Freaking thing. So check your sketches if it doesn't continue, or if you don't get that blue halo, like now, sometimes it's an open sketch. You want to make sure to address that. So let's just trim up the excess. Great. All right. Now that's real basic. I can, of course, go in and let's go ahead and fillet these. That side, that side, that side, that side. Those are going to be the same. I'm just going to close this fillet up a bit. Oh, now see, this is one of the problems with adjusting fillets inside a sketch. Because these are linked and because I use the offset tool, it's giving me some really weird results here. So this is one of the cases that I have run into that it actually works better to not put the fillet into the sketch and instead put the fillet into the actual extrusion. So let's just escape out of that. Control Z, or honestly, the other way would of course be creating it. Whoa, what just happened there? Let's see if it'll let me work. Try to get that to about half. So let's say 3. Repeat that fillet. There and there. See what happened is now it's trying to push that other line out. So we're just going to ignore that. Control Z. I'm just going to leave these corners square. All righty. Okay. Lots of dimensions, lots of small measuring, but that's what this project is. That's one of the aspects of this project, is making sure you have a complete set of dimensions and such. Okay, finish sketch. Now I have 1/2 of a pair of pliers drawn out. Now there are, of course, additional features, things like the teeth and such in there. We're going to model that stuff later. I'm not going to worry about it right now. Right now, I just want to get the basics down. Okay. Now let's see here. Let's pause there and check. Okay, so I've got the basic sketch laid out. Now what I'm going to need to do is create my sides from that sketch. Now, the reason I created this sketch in the main section here, and let's just relabel that as pliers half, is now what I can do is, since it's out here, I can now activate my side component and extrude that sketch. And the reason I'm doing it this way is simply that that is now halfway. That is now right in the. I'm already going to be building it, even in this component. Even though I'm selecting from a sketch that exists outside the component, it's building it inside the activated sketch. Now, your first thought would be, okay, I'm just extruding it. Let's see, it is 9 millimeters thick. So just go 9 millimeters straight up, easy peasy. This is most certainly the simple way of doing this. However, this can make it a little more difficult. The reason I say this is because even though the full set of pliers is 1/2 and 1/2, that center point is halfway through the thickness of it. So it actually makes it a lot easier if instead what we do is extrude this halfway and then don't select other parts and extrude it the other half. So it's 9 millimeters thick. Cool. All right. Now this requires 2 separate extrusions rather than a 2-sided one, because I could ideally say, all right, well, let's make it symmetric instead and whole width, and it starts in the center and goes both up and down, or 2-sided and one side is 4.5 and so is the other. That would make sense, except what I want is to not extrude half of this. Now, the other thing I could say is, you know what? Just do exactly that. So everything is on the center line, easier to work that way. And then I could just extrude that sketch out, which honestly, I think now that I've said it that way, I'll do it that way. Otherwise, there's going to be 2 separate extrusions fused together. So I'll just unhide the sketch of that, of the pliers half. I'm going to create another extrusion. But what I want, I'm going to expand all this, hide the body. I want just that inside. Now I can extrude from there. I'm going to use extent type to object and just select the top side of this pair of pliers. Now it just extrude cuts out that chunk. Okay, great. Actually, that worked really well. We'll do that from now on instead. Same diff. The only reason I'm saying use a 2-sided one is, or I guess in this case, you could have just done symmetric, is because I want that flat spot, this little recess, the inside of the pair of pliers. All right, great. So let's go ahead and finish. Let's go ahead and clean up this pair of pliers, and then we'll cut through the inside sections and such. All right. So what that means is, first I want to fillet on this edge to replicate the rounded pliers. I'm going to use the slider on this, and I'm just going to drag it inward until it looks about right. All right. Now, technically, these pliers are also pointed downward. Excuse me. And that honestly wouldn't be that difficult to do. But for the sake of time, let's just do it this way. All right. So you got a pair of pliers. You're all set there. Okay. Like that fillet. All right. Now let's start rounding out some other stuff. Let's do fillet that one, and just use the slider, drag that inward. And so you see now, since I was having some difficulty adding the fillet to the actual sketch, now that I can do it on the body, works just fine. There we go. Okay, that looks good. And yes, I know this one technically has a dip side for the grippy part, and this one does not. We're just going to ignore the grip thing for this part. So let's do another fillet of rounding out these corners. Select there. All that's good. All righty. Drag those inward and make for some nice rounded pliers. That works well enough. Again, we're not going for absolute photo accuracy, but the dimensions and such are important. Okay. Select OK. And we can probably do one more quick one there where that cleans up that edge. A little bit of rounded round. Yeah, that works. Snazzy. Okay. That works well. Well enough for now. So we'll go ahead and save. Pliers, half extruded. Cool. Okay. So what I'm going to need to do now is I need to create the other half of the pliers. Now, the reason I selected all of this the way I did, the way I modeled it the way I did, now I can just take this pair of pliers, make a copy, and rotate it. We could also use the mirror tool, but this actually isn't technically a mirrored side. It's actually the exact same tool. It's the exact same part, rotated 180 degrees. It's not a mirror. So that makes it a lot easier. So what I'm going to do is I'm going to go back and activate the whole project because I don't want to create this inside of here. I'm going to now select that body. So let's just say side one. I'm going to make sure to label those so they stay all proper. And I'm going to copy and paste. So Control C, Control V. Boop. Second one. Excellent. Now I need to rotate this. However, where it defaulted to where the center point is, if I rotate it from there, it's just going to screw up the whole thing. So no, that's not what I need. What I want to do is at first I want to move the center point. So what that means is on this toolbox, select pivot point, and I'm going to select right in the middle there. It snaps all over there already. Great. Now you do have to go back. It says, all right, a little check mark, all set. Go back, deselect that check. Done. Now I can rotate this 180 degrees. Just put it in numerically. Whoop. Looks like I did not get it smack in the middle there, so that's going to be a problem. I'm not sure what it selected. It selected a point of, I don't know, something else. That's odd. So then tell you what, let's just cancel that. I'll do it again. Select, Control C, Control V. All right, I need to select center point. Not sure what it selected last time. Let me zoom in here. Rotate around. Not sure. Select there. All done. Deselect. Now let's rotate that 180 degrees. There we go. Got it that time. Okay. Now before I hit OK, move object, all of that. Remember I went out. I have the whole project activated, not just the component. I have the whole project activated. The very top option here on the Move Copy toolbox is Move Object, Bodies. I can select Component, and it'll select the whole thing. Damn, it's not showing me. Sometimes I'm not sure why, what the defining factor is. You should be able to drop it into another component outright. That's okay. Sometimes it seems that depending on the function, sometimes you'll be able to. It's not allowing me to, so we'll just leave it as bodies, ignore what I said. Hit OK. Great. Now they're both this green because the whole thing is activated. If I select the project there, you'll see that I have that one there. That's okay. Okay. So go out. Oh, whoops. Looks like because I Oh, I've got two bodies there. All right, let's figure out which one is the right one. I messed up here. We'll go with the one that's not rotated. Oh, that one. Delete that. Okay, there we go. So let's rename this. When I rotated the first one, I copy and pasted the first one. I didn't delete it, and it just stayed there. I didn't realize that. That's probably why I got some weird reaction. Okay, so when I deselect this, yes, this is showing us two separate components. That's because the green one is the color. If you look up, since I have it on auto colored mode, which is Shift in, Shift November, the whole project is this lime green, and component one is this burnt orange. Okay, I need side two to be its own other component. So I highlight side two, select out of the bodies, go up to assemble, new component. There we are. From bodies, it's from that body. Boop. Created a whole nother body, side two already labeled because the object was labeled. Side two, it's that turquoise. There we go. All right, excellent. I now have my two halves of the pliers that are matched. It's not a mirror, it's a rotation of the exact same tool. But this is why I created the sketch in the full project, so it didn't get hidden or stuck in one side or the other. The reference sketches and plier half sketch is in the main component, or the main project component. That means just the bodies and origins are within their own respective components. Okay, so let's save there. Side two, component done. All right. So now what I need to work on is I need that center part and the joint. So let's go ahead and hollow out the center first, and then I can work with showing you how to create the joint itself. So what I mean by hollow out the center, I'm going to hide these bodies, bring back the sketch, and let me start a new sketch right in the center. And all I'm wanting to do here, oops, looks like I accidentally selected the wrong plane, so let me delete that. I need, no, delete, not create. What's going on here, buddy? There we go. New sketch on the bottom, but I'm going to start right in the center here because I'm going to use this sketch to create both my snap fit joint part and also use it as a place to use the extrude tool to slice into the sides. So just as reference, I'm going to use, you could barely see it on my pliers here. I'm just going to take a measurement with my calipers to take a measurement of that pin inside. It's about 8 millimeters. All right, that's fine. So center point, right from the center of that circle. Oops. Helps if I actually select on the center. Hey, there we go. 8 millimeters. Great. Okay. So right there, that's good. Now, for the moment, that's all I need because I'm just going to hollow out a section. But I also want to go ahead and borrow this line. And I don't feel like drawing more circles and remembering what it actually is. So I'm going to just project it. Press P, or you can go to Create, Project, same thing. I just want to copy this outer circle. Okay. Because now when I deselect the and hide the original half sketch, now that circle is just purple. Just helps me out there. Okay. And I'm going to use that to extrude. It's hard to get at it, so let's just hide. Need that sketch. There we are. And for the moment, just to demonstrate what I'm doing, is I'm going to extrude all the way through this thing. So start at the profile plane, distance, symmetric, overall, extent type, all. That just slices right through, but it's defaulting to new body. I don't want that. I want cut. All right, why is it not cutting through? What? Where'd my cannot complete extrusion? Why? let's see, something, 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 objects to cut. Because I didn't select anything, that helps. Usually it'll automatically go through, because I need to cut through those objects to cut. Why is it not going through? I don't know. So let's just do one side. Don't know why it's doing that. Should be fine. Two sides. Because I originally made that as a two-sided object. Extend type, two object. There we are. And then the other one, extend type, two object on the bottom. No problem. Okay. So essentially the reason it wasn't working is because I originally created this extrusion as a two-sided extrusion instead of symmetric. If I'd done it as symmetric, it would have been able to just understand it easier. So I just had to match up the direction type. So two sides. If instead I'd done symmetric, it could have done symmetric. That's all. Okay, problem solved. Great. Okay. I just created that hollow space. Ultimately, I'm going to create a pin that goes in there, but I want to show you quickly the joint tool before we get into modeling an example of a fit point or a snap fit part. All right, so I hollowed out the space. We want to create a joint. Now you mouse over to assemble. The other one that's under next to new component is joint. Now joint, or you can just press J as the hotkey, creates relative movement relative to two different components. Now that is a major feature. This project must be two separate components, not just bodies. If you accidentally create them as two bodies and such, select that body, create new components with them. A joint only functions between different components, not bodies within the same component. You can nest components within components, which just makes your eyes just go cross, but that can work too. For now, we're just using two surface level components. If you select the drop down, you can see there's a bunch of different joints that you can select as. We're using the basic joint tool, which is the one that should be default up here. All right. So you see from the toolbox here, you have your position selector, which component 1 and component 2. If you have two components that are in different places, you can use a joint tool to actually snap them into place. So the key to selecting or your selection for components, the first selection, component 1, is what will move. Component 2 is where it will move to or relative to. So what that means is in this case, it doesn't really matter because this is a simple side to side and matched pair of objects. But if this were, say, like in the next project, it's going to be a hinge. So your lid and your box, well, only one side will move, that sort of thing. That's what's important. In this case, it's just here. The second tab on here is the motions. We're going to get to this in a moment, but this goes through all the motions. Sorry. You have your different rigid joints. Revolute is what we're going to be using. It revolves. You have your slider joint, which is just that, slides along a path. Cylindrical slides and moves up and down. So like a threaded screw or something. You have pin slot, which is really cool for actually creating like machine channels into things. So something can move along like a cutout groove. Planar, which means it's basically just, it can slide around a flat surface. And then ball, that's where you can create actual rotating joints, like a ball joint, like your shoulder. And the first one is rigid joint, which I realized I didn't actually say. Rigid joint just locks the two things together. Basically, it was like if you were creating something that you intended to print in two separate parts, but we're going to glue together, that's where you'd use a rigid joint. It's two components, but you want to lock them together as one solid thing. All right, so position. What we want to do is you want to select the exact center of where something's going to move from. Now, if it's like a long cylindrical thing, you could probably select anywhere along the surface or along the length of that movement. Here, what that means is the center of our movement is right in the middle of this hollow space, but it's also right between these two halves. So the easiest thing to do is hide one of the components, make your selection, then unhide that, hide the previous one, and then select the other half of it. Let me show you what I mean by that. So first I'm gonna hide side 2. I need to select right out here. Now the selection process has improved greatly with Fusion. We're just gonna leave with the simple selection. You have other options here. You have between two faces, which technically would work here also, and then also 2 edge intersection. We're not gonna worry about that stuff right now. We're gonna worry with just simple selection. I need to select right there in the center. Now that actually worked. Awesome. If you are having trouble selecting, mousing over in the center, let me orbit down. You can see that I'm actually selecting in the center of that cylinder, or that cylindrical space, but flat with this plane. If you are having trouble selecting that, maybe your selection is jumping around, something like that, what you can do, if you intend to select a space in the middle of something, but along a shared plane, mouse over the top of the cylinder, press and hold Control. That locks your selection to the current plane that it is highlighting. Now I can mouse over and it snaps right to the center. It will not select anywhere below this. Won't even select up top or below. It's only on that plane. Make sure you're actually in the center. I'm not sure what I keep selecting there. Right there. Now my first selection, after my first selection, the first component ghosts out. But I also have the second one hidden, so that kind of creates problems. Okay. Same deal. Selecting under here. If you're having trouble selecting even with the ghosted out thing, hide the first body, or a component rather. Again, pardon me. Mouse over the surface, press and hold Control, snaps right to the center. Make sure you're actually getting the center. There we go. Unhide the 2 halves. There we are. That's exactly what I want. It's going to move there. Now, over to the next tab. Right now, it is default selected as a rigid joint. I press animate. The whole thing shakes and gives you anxiety. Don't do that. It's just demonstrating what's happening. Select revolute, and you can choose your axis. Now, again, kind of freaking you out. We're moving it along the Z-axis. If you actually needed something else, that's not how pliers work at all. Not at all. So you can see how you can go through these. Again, just wrong. So on the Z-axis, great. And we're going to set the limits and such on that in a moment, but that's how you make that selection. Again, you can animate it if you just need that satisfaction. Okay, there you go. Now it is joined together. So let's save there. Joint added. All right. Now, once you've done that, you will be able to select and drag 1/2 and it'll animate. Oh no, it's moving the whole thing. That's not good at all. Now again, thing pops up, capture position, revert position. New options up here. They just appeared because something happened. This happens if you move something and you are not sure if that's where it wants to go, or the program isn't sure if it wants to go there. You can capture position. Yes, I want it to be in that new location. No, I don't want it to be there. Hit revert. There you go. Now the reason it does that is because one of the halves of your joint must be what's called grounded. It literally must be locked into that virtual location in the digital environment. So to do that, all you have to do is decide which side you want. Doesn't matter which side. I'm going to go with the lower one. So this one is technically on the bottom in these orientations. So side 1, right click on side 1, second selection from the top, ground. Boop. Now on that component, you'll see this little pin, this little push pin symbol. Now that component is locked in that virtual position. It will not move. So now, and that also means if I wanted to move the actual object, I have to right click and unground it. But now I can click and drag on the other one, the other component, opens and closes. So you just have to ground that part. Now again, this is where the capture position and revert position really make the most sense. It's really meant to be with working with a joint tool and such. This is if you wanted to build the object, but display it in like an open or action position. that's really where the capture and revert position tools come in play. I want it to snap back to where it was, so I'm going to go to revert. All right. So let's close these just to clean up what I'm working with. Now you can also see under my hierarchy tree, joints has created a folder for joints, just that one Revolute joint. Now what I want to do is constrain it, because right now I can move it way further than it needs to move. Again, revert. What you do, go to that. You don't right click, you just left click on the little down, looks like a download button. What I want to do is I just want to create minimum and maximums. Now you can either do this numerically, or you can do it with these little flags. If I zoom in, unfortunately, those don't scale with it. So sometimes it's easier to see them if you zoom outward. But if you grab that flag, you can move it around. So ultimately, let's go to, I want that to be minimum of 0, and I want the other. Let's move you to 35 degrees. Now, one of the problems with this model is my sketch. These actually need to be tapered. As you can see, it technically should open more, but those two parts intersect. So I can always go back and fix that in my sketch. But for now, we're just going to leave it as right there. Is that hitting the same way? Looks like there's something very wrong with my drawing, or with my joint. I think I selected that, whatever that weird point was, just ever so slightly out. You see how it's not lining up there? I'll have to fix that. But okay, so there we go. It is open up to 45 degrees. Now, when I animate, it will only go, I don't know where that -25 went to. There we go. Back and forth, only 45 degrees, back and forth. Hit OK. Again. Now, when I move that, it will only go so far. Great. Okay. So that now lets me lock those in position. So save again. Joint defined. All right. What are we doing? So that's pretty much that. Last step with this is I just want to create a quick, simple snap fit joint, or a snap fit joint. Now, looking at this example here, let me hide one of the sides. And with this, you can see simply looks like a cylinder with this flare outward and a couple of slices made into it that'll allow those tines to flex ever so slightly, or at least that's the hope. So we're just going to model something simple like that. So what I need to do here is I do want to go back, and in this case, I can either create this as the snap fit goes as a separate part entirely, or I could model it built into this pair of pliers. I think I'm going to model it into the pair of pliers. So what I'm going to do is I'm going to go back and edit that extrusion that cut through both halves. And I'm just going to select it as one side, and it just cuts through the one component now. So it's solid on the bottom. There we are. Same deal. I just cut that away. Okay. So the other step is I need to actually make that little tab. So let's go back to the previous sketch, to there. Let's hide some parts so I can see what I'm doing. And there we go. So what I'm going to need to do is I'm going to need this to flare outward a little bit and such. But I need to also consider clearances. So that hole I cut is 8 millimeters. I also need to make sure that, like the description said, somewhere consider at least a 0.1 millimeter, maybe up to, I would say probably don't need more than 0.2 millimeters. 0.5 is a lot. So I'd say probably 0.1, 0.15, 0.2, somewhere in there. So what I mean by that is I want to create another cylinder, or a circle rather, right smack in the middle, and I'm just going to make it 2 millimeters thinner, or work smarter, not harder, just use the offset. That way, if I make any changes, this will automatically snap. So I'm just going to put negative 0.15. Tiny bit smaller. I realize I was saying 1.5, probably 0.15. Okay, so right in the middle. There we go. That seems like a lot, but might take up some extra space. Now, the other thing I want to do is I do want to find a way to give myself a little bit extra clearance with this cylinder here. So I'm going to use that outer circle, and I'm just going to make like a 0.1 millimeter wider, just a little tiny bit out. That's it. Oh, okay. So I'm going to use that to extrude outward and slice just a little bit away from the pliers later. Select OK. All right, finish sketch. All right, and of course it hides the sketch, blah, 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 blah. Where did my sketches go? All right, now I'm going to label that. We'll just say center pin. Okay, great. So unhide all the things. There we are. So what I'm going to do now is I'm going to extrude that center sketch. If you're having trouble, as always, just hide some parts. But select there, and I want it to go up at least as high as this part is. Make it easier. Extend type to object. Select the top there. Comes up to there. Now I can leave it as join because it's not linking with the other parts. See, it's got this little tiny gap here. Good. That's exactly what I want. Select OK. Now I need to create a profile outward. All right, because I need that to have a little tab. I need there to be a little tab. I can create a chamfer on this corner here. That'll replicate that. And let's say, I don't know, 1 millimeter. That's freaking huge. Let's say more like 0.5. Much smaller. I just need a little bit of a tab, a little bit of an overlap. There we are. Okay. And this is what I meant by duplicating something like this. See this little tab here? The other part needs a little place for that to go. But make sure to also put a chamfer on the inside edge so it actually helps force that pin in. So don't forget that. I can always go back, edit the feature for that part, for that one. Let me hide side one so I can get at the bottom there. Make sure there's a chamfer on that one also. 0.5 right there. 0.5. There we go. I just want to make sure that part will go in a little bit more easily. Great. All right. Now there's of course plenty of ways you could do this. Unfortunately, you can't just extrude outward, something like that. But easy way to do is I can create a sketch on top, which I know it gets really tiring. All right, create a sketch. It's just how this program works. Create a sketch, but actually I'm going to work from up here. All right. And I need something that's going to be about that big. So I've got a sketch. Let's project and copy this outside circle. And that'll work. But also I want this outside edge to match that chamfer. So again, select project, select there. Okay. Let me hide the body so you can see what I'm doing here. I created a sketch up here that copies the edge of the chamfer I just created. You have to create that chamfer to copy this edge. That's all. All right. And I'll probably go ahead and add more to this in a moment, but let's show you the steps why I'm doing this. Finish that sketch. All right. The other thing I need is how tall is that chamfer? So I can select measure. See if it'll even let me get to that. I'm going to have to hide that sketch. It's not even letting me select down there. I need to select from that edge to this surface. All right, that figures. It's giving me, of course, a diagonal rather than a direct linear. Ugh. Sometimes the measure is really obnoxious. So let's try from that cylinder to this surface. Same problem. Dang it. All right, fine. We're just going to estimate this. So the reason I'm doing all of this is let me unhide those sketches, all of that, because I'm going to hide that part and I'm going to extrude there to there and just extrude downward a little bit. That's probably going to be way too much. Let's hit OK there. Okay. Say that's good. Obviously, that's a problem. That's not going to work because that intersects there, but it is the right size. So let's use a chamfer right there. Chop that inward. Yeah, I want it to cut. Fine, let's say 0.5 then. There we are. So something like that. Now that's still not going to be enough, but let's select OK. What I mean by not going to be enough, if you're trying to see through something, visual style, hidden, and you still don't get a very good idea. So let's switch to wireframe. There we go. So you can see what's going on here. As long as your image actually stays put. What just happened there? There we are. That just got totally lost. That's not helping at all. That's exactly the opposite of helping. All right. So let's just work with that. So all that means is that extrusion was just too much. I was kind of figured that much at 1 millimeter. Let's just say negative 0.5 instead of 1. There we go. So now when it snaps back together, there we go. Just that little, now there's just that little tab. That should work. It's the same size. It's a little bit large, but that's all right. But it's going to match that inside of that chamfer and all that. Great. That's all I really need. So let's just clean that up a little bit, just to roll those edges a bit. That actually might not be. That might be too much. So let's make that a little bit larger. Edit that. 0.6 maybe? See, it's not going to let me go all the way there. Cancel. All right. So I might just have to shrink that sketch just a little bit. Namely because I don't want this lip, because I can't have that lip there. So let's go back, edit that sketch just a teeny bit. Realistically, the other option would be I could just create a triangle around that and just revolve it. But let's try this. God, I'm getting confused as to what I'm looking at here. Too many sketches. There we go. All right, so what that means is let's just go ahead and all I need to do is just shrink that outer edge just a little bit. Let's say negative 0.1. Yeah. Again, we're working with the 0.1 millimeter offset. There we go. Okay, cool. Let's do that. Yes. Unhide all the things, all of that. I just want to edit that last extrusion. Where am I? God, I got lost on my sketch there. There we are. Excuse me. And I just want to deselect that. So let's select that. There we go. So it's just a little bit of a smaller circle. That's all. Join. Edit feature, because now I have to just fix some stuff. 0.5. Yeah, that's a little better. 0.6. Will it let me? Nah, looks like it's maxing at 0.5. Let's see. Hopefully that should work. That looks like it's got enough clearances. And if not, you can always just smooth some of this stuff out with like a fillet or something like that. Just so it matte. Probably not going to let you do too much. Yeah, sure. A little 0.2. That might work. Main thing, we're just trying to avoid anything running into each other. But since I shrunk that inner circle there, you see how now there's this gap? That's all. So all I'm doing is I'm just playing with some different distances, and I'm holding to like 0.1 millimeter gap. That's all. Last thing here I want to do, like it shows in the example here, or on this example here, this reference, is I just want to slice some sides down through here. So hopefully, rather than that being a whole cylinder like it is now, let me hide that. Rather than that being a whole cylinder, I want to slice that up a little bit so those little tabs have a little bit of room to squeeze through. So all I'm going to do is I'm just going to cut. Cut some chunks into this. Okay, cool. So last step here, I can probably go back and edit that other sketch, but let's just start a new one so it's easier to deal with. So edit sketch right on the top of there. centers me out. Did that just zip upside down? No, we're good. Okay. So first I'm going to make a center circle and just draw out, I don't know, let's say 5. Yeah, 5 seems like it's a good amount because I'm going to cut that through, and then I'm going to create a line out to slice right through all of here. So what I'm going to do, let's see, easiest way, yeah, let's use a center rectangle, selecting in the center. And I just want to make sure that it goes all the way out, but let's go a little bit further. So, 10 sounds good. That's on the outside. How thick? I don't know. 2 looks a little bit large, so, and 1 looks a little small. So let's split the difference, say 1.5. That works. Finish sketch. Okay. And since we're just going to do all this in Sketch, no problem. I'm just going to copy that and rotate it, or I could just make another one. Same diff, doesn't really matter. Let's see here. Yeah, we'll just do it that way. Oh, I finished the sketch. Whoops. I meant to add another rectangle there. There we are. And what were my measurements? 1.5 wide by 10 long. Cool. Okay. Select OK. Now I'm just going to cut right through here. Now I got a lot of lines to deal with here. That's okay. Well, let's select extrude one last time. I got to select all these little chunks here. This kind of gets a little tedious. Want all of those. Realistically, the other thing I could have done is just hide everything for a moment and just done a selection box around this, but this works. Okay. Direction, one side, start, right where it is, profile plane, extent type, to object. And I'm just going to select down here on that next surface. And there you go. I just chuck those chunks away. Boop. There you go. That's it. Easy peasy. Now, I said the last thing. Everything's got one more last thing. As we said before, these sharp corners, like on here, makes for a weak spot. But let me toggle which one is hidden. We duplicated this chamfer on the bottom too. So it's got a little wiggle room. So let's add a fillet to this bottom just to help strengthen that. So problem here is I got to go around and select all of these edges, which gets, again, tedious. Realistically, I should be able to select just this whole surface, but I don't want to also select all of these. So I got to go around and just select a bunch of lines. I really wish they had a filter selection here where you could just select all the things without having to actually select all the things. This gets a little tedious, yes, but I know. I hate having to do all these little fine selection things, like having flashbacks to like Microsoft Paint, or if you make one mistake, you gotta Control Z and start all over. Okay, that ought to do it. Now remember, our chamfer was 0.5, so we can really only do 0.5. That's a lot. We better shrink that down a little bit. Let's half it, 0.25. That should work. So all that is just a little fillet at that bottom edge. Helps with a 3D printed object. A sharp corner is a weaker corner. A little bit of a fillet, a little bit stronger. There you go. Okay. So let's save again. Snap, fit, pin, done. So now, unhide. There we are. So there's a lot of steps. I recognize that, but the main thing is you are just dealing with taking a bunch of small measurements to do this. The main new tools are learning the joint tool, making sure to ground one side or the other, and then modeling some sort of snap fit pin. Now, I don't expect you to automatically know the engineering behind snap fit pins. That's why I attached the articles that you can read through. you can use some relative dimensions. That works. That should work well. If we were to print this and it fails, all right, well, that means we need to either use a stronger material, check your layers, maybe make it a little bit finer, or make these tines a little bit thicker. But for the most part, that's really what we're going for. My part moves. I should fix a little bit of clipping there. That just means I just need to edit the sketch a little bit. That's fine. But the thing all moves. And there we are. So there's a few new tools, a lot of different ways to use them. As usual, we're working with a lot of simple tools. It just depends on how creative you get with using those. So very best of luck with it. As always, ask me questions. And also, there's plenty of additional videos and such on doing exactly this. So if the way I'm describing it doesn't make the most sense, there's other ones that can make much shorter videos of doing the same thing, but I go through longer explanations because we're explaining why I'm choosing to do those things. So very best of luck, and as always, ask me questions. And where is the stop? There we are. Okay.